Hello everyone, welcome to Data Analytics and Visualization Tool presentation. Data Analytics Fundamentals. Now, data analytic goal is all about data meaning. Beyond understanding data context, it has four key data manipulation components to meet its goal. And these are ability to inspect data. Number 2, ability to clean data. Number 3, ability to filter data. And number 4, ability to plot data. Data analytics how-to. Well, data analytics discipline at the very least requires understanding and familiarity with, number 1, data analysis frameworks. These are specialized frameworks such as Pandas, Vaex, DAV, and others. Understanding about specialized platforms such as Jupyter Notebook to implement data analysis frameworks. Our ability to code in multi-purpose languages such as Python to leverage data analysis frameworks, and to use specialized statistical and plotting libraries. And finally, our ability to produce various dashboards to showcase data. Data analytics challenge. Well, data analytics is the need of our time, and it's a reality for people in various disciplines, from academia to business and industry to scientific community and everyone in between. Data science and data scientists represent domain expertise that ordinary data users do not possess, and it requires considerable amount of training and experience to reach that level of proficiency. Even for data scientists, writing new code and scripts to manipulate and analyze and present data can be challenging and time-consuming. Against the data analytics challenge that we covered in the previous slide is an opportunity for automation support, and that's where DAV tool, or Data Analytics and Visualization Tool, comes in. Well, this is a general purpose tool built to meet basic data analytics needs of most users, and it overcomes the challenge of rework and scripting to analyze various types of datasets, small or large, which means ranging from hundreds to millions of records, and this we can perform on our laptop or desktop. The operating model of DAV tool incorporates data analytics fundamentals to inspect, clean, filter, and plot data. The tool is designed and built with inherent flexibility to incorporate additional features within its operating model components. The tool also demonstrates capability to leverage specialized languages like Python within the Jupyter Notebook platform using the best of Pandas, Vaex, and DAV data analysis frameworks. Having broadly described the DAV tool, it's now time to demonstrate its capabilities, and in doing so, we will be able to open datasets of various formats and sizes. We will inspect, clean, and filter and plot these datasets. So let's begin. Welcome everyone to Data Analytics and Visualization Tool demonstration. This tool is a dashboard that enables us to inspect and clean a dataset, to filter it, and to plot it. We are currently on the main screen of this dashboard, which has two capabilities, our ability to inspect and our ability to clean a dataset. For the purpose of this demonstration, we will use this scenario. Number 1, we will load a large dataset file, and the file in question will be that of New York taxi cab data from 2020. We will inspect this dataset by running a number of reports. Through these reports, we will identify an opportunity which will lend itself to the subsequent feature of this dashboard, which is to clean and transform the data. So let's start. We pick from the file option from our data directory the New York taxi cab data. We have loaded up our data file, and as you can see, this dataset consists of over 6.4 million records. So now, in order for us to profile this dataset, we will have access to a number of different reports that we can run against it. So let's look at what reports are available. The first set of reports that is available to us is detailed stats on this data set. So let's run that report now. Here's the report. As you can see, it's a very elaborate report. For each variable, it provides us with total number of records there are in the data file for that variable, the type of data it has in terms of its classification, how many unique values it has, how many missing values it has, top value and its frequency as it relates to non-numerical values, as well as for numerical values. It provides a breakdown in the form of mean, standard deviation, minimum, quartile values, as well as maximum value. So again, a very elaborate and comprehensive report on this data file. Now let's look at what other reports are available to us. The second report is simply a subset of the first one, which is data classification by variable. So let's run that report. Here's the result, a very streamlined report. For each variable, it provides this data classification. So from top to bottom, we can see the data classification consists of float values, string values, and integer values. Interesting thing we note from the top is that there are two variables which actually contain date and time oriented information, but their classification currently is string. So this is something we need to focus on and clean and transform, because in order for this data file to be useful for filtration and subsequent plotting, is best that we convert these two variables from their current string classification to date and time. So a very useful report and a very useful indication of what kind of opportunity we have in terms of data cleansing. Let's look at the third report that's available to us, and this is again a subset of the first one, which is unique values, how many they are by each variable. So let's run this report. Here are the results. Again, a very streamlined report. For each variable, it provides us sum of unique values that it contains. Let's look at yet another report, and this one is how many missing values there are by each variable. Again, a subset report based on the total statistics that we earlier saw. But let's move on and run this report as well. Here are the results. The report basically indicates that number of variables are missing values. For example, the first variable in this data file, vendor ID, is missing 65,441 records. Likewise, there are additional variables too that are missing values. So this is another opportunity for us that we can target in cleaning functionality of this dashboard to basically transform this data and remove these missing values, so that subsequently we are best able to analyze this data as part of filtration and plotting it. So this is another very useful report that we have. Now, related with number of missing values is a view of the data which actually shows the records of this file where there are missing values. So we can run this report as well now. And here's that view of the data. You can see in this particular view, we can see that these are the total number of records that are missing, and these are the actual record number in the file where there are values missing by certain variables. Very useful again. So now we can move on from here into cleaning this data file based on the opportunities we have targeted. So let's move on to the cleaning functionality. As we enable the cleaning mode, we now have additional set of features that are available to us. So the first thing we need to do is we need to remove missing values records so that our data can be cleansed from this one defect that the data file has right now. So let's execute that function. Here is the data file view. After we remove the missing values records, you can see that initially there were over 6.4 million records, and now that number has been brought down. Additionally, we also had opportunity to transform two variables, which are pickup date and time and drop off date and time. The reason why I need to transform these two variables is because both of them currently have their data classified as string, and we want to convert them into date and time. So let's do one of these variables at a time. So we convert it into date, and now we move on to changing the data classification for drop off time. We have done that. Now we're actually going to go back to inspect and rerun a couple reports to confirm that the cleaning operation that we have done, it has actually taken effect and the file has been updated. So let's go back to inspection and we run variable data types report. Here's the result. As you can see, now pick up date and time and drop off date and time, the classification has changed from string to date and time, which is what we wanted. Additional transformation we did, we removed all missing values. So let's run that report as well now. Here's the result. You can see there are no more missing values in this data file for any of the variables. So in actual fact, we have been successful in cleansing the data in the areas that we targeted. Additionally, as part of inspection, there are two additional reports that are available to us as well. One is a correlation table and one is a heat map. So let's look at the correlation table first to see the relationship of each variable. So here's the result of the report. It basically indicates what's the correlation of one variable to another, and it's a useful breakdown of that particular correlation. We also have another view of this information, and that is in the form of a graphical heat map. Let's run that report as well. So here's the graphical view of the heat map. It's very interactive. As you can see, for each variable it tells you what the correlation is and how closely it's related. So very useful report of this particular data file. So now in essence, we have demonstrated for this file two key capabilities. We've been able to inspect the data, profile it based on running series of reports. We identified opportunities to clean the data, transform it, and subsequently we were able to see its correlations as well. Now we are able to move on into the next feature of this dashboard, which is to do with filtering this data based on criteria that we would like to deploy. So let's click on that. Hello everyone, so we have now come to the filter functionality of data analytics and visualization tool. Prior to this, as we demonstrated in inspect and clean functionality, we had loaded up New York taxi cab file, and in this file we performed three specific transformations. Number one, we removed all records of missing values. Number two, we changed the date format of pickup date and time and drop off date and time from string to date and time. So now as part of filter functionality, we will demonstrate how we can actually slice and dice this file based on applying criteria where we will focus on certain variables within their value thresholds. So let's start this particular demonstration by looking at the GUI, what it offers us to facilitate this feature. So as you can see, under variables, there's a drop-down list. It gives us all the variables which are applicable to this file. Under operators, we have a list of all the comparative operators that we can apply on value of any given variable of interest to us. So let's pick up to start off with the pickup date and time variable. As you can see, the GUI is very sensitive to the data that we're examining, and it realizes that we're working with the date and time variable data. So as a result, it has adapted itself and has given us two further data selection features. One is a scale for date. The second one is a scale for time. So using the date scale, we will focus on a date range between starting here and ending here. Likewise for time, we can select time frame from here to here. We go to the operator drop down list, and we want to select all records between this date and this time range. So we select that operator, we lock the date and time, and then we start our search. So here are the results. It has basically done the search and is now giving a view of the data file which meets this filter criteria. We will select another variable to further refine our search, and we will pick up passenger count variable, and again within this value thresholds we select a value, pick an operator. Let's say we want all values greater or equal to 4, and it has now given us a view of the data file whereby initially we were at 6.3 million records, and now we are down to 481,000 plus records which meet this filter criteria. So we always have the filter criteria as a context in front of our in this box for which these are the matching results. So let's continue and further refine it. Now we pick trip distance as our third variable of interest. We again select a value threshold and we say give us everything at least matching and greater than this value for trip distance. Now we are down to over 29,000 records. So as you can see, very easily this GUI is giving us ability to filter this data file based on criteria that we are applying for variables of interest. Let's even do one more. So we have now a variable called store and forward flag. And as you can see, again, the GUI has adapted itself and now is giving us a drop-down list to choose a value from. So let's choose a value of y, and the operator we'll choose is equal to. Here are the results. As you can see, we now have 102 records that match this criteria based on 1, 2, 3, and 4 variables of interest and their value thresholds. Very easily, we were able to slice a very big file, over 6.3 million records, down to 102 records that meet this criteria. And if we wanted to start our filter process all over again, we could easily do that by clicking on this button, clear filter, and it will take us back and we could redefine and refine our start of filtration one more time. So a very easy way of performing filtration, which is a key component of data analytics and data analysis. So hopefully this gives you a perspective of what's possible in leveraging this tool. Now, having said that, the next key component is how do we plot the data? So we have cleaned the data, we have inspected it, we have filtered it. Now we're going to be moving on to the third functionality and the third component of this tool, which is plotting the data. So let's go over there. We will now demonstrate the plotting capabilities of the data analytics and visualization tool as it relates to the file under review, which is the New York taxi cab data file. And in terms of the GUI that we are observing right now on the screen, we can either plot the full file or the filtered view of it. And in terms of selecting variables, we can select up to 3 variables, X, Y, and Z combination. Let's start off with just one variable, and we will select trip distance for the full data file. And from the list of available plots, we will pick a plot that best helps us examine the distribution of this one singular variable, trip distance. Here is the result. So we are getting 3 different plots for this one variable and its data: a box plot, a distribution plot, and a count plot. We can also select another variable for y and see how the 2 variables relate to one another. So for trip distance X, we have trip distance. For y, we will select fair amount. We will select a scatter plot. Here's the scatter plot for these 2 variables, trip distance against fair amount. We can also actually select yet another scatter plot to examine the data in another perspective. So let's select that. Here's yet another scatter plot, and the difference here is that we can interactively examine each data point. So an interesting way of examining how the data is spread against these 2 variables. We have yet another perspective that is available to us as well as part of the plotting feature. For examining any large file, we can examine a third variable as well. So pick for our Z dimension or the Z variable, tip amount. So now we have 3 variables, X being trip distance, Y being fair amount, Z being tip amount. So let's see how these 3 variables correlate to one another. Here's the result. We have various plots that represent combination of correlations between variables that we have selected. So yet another very useful way of looking at the spread of the data. So far we have examined all of the data for New York taxi cab as full data set representing over 6.3 million records. Now we can switch to examining the filtered view of the same file. So let's select filtered, and again we will leave the variables as they are and examine them individually and in terms of how they relate to one another based on the plots that are available to us. So for trip distance, let's look at the list and let's look at a box plot. So here is a box plot view of the data for trip distance. It's interactive, so you can see all of the quartiles that's available. We can have yet another perspective as well, and then for this case let's switch to not only having an x variable but also a y variable. So we will examine how trip distance and fare amount relate to one another. So here's the plot for all the records within the filtered view of the file. We are examining how this data is spread out for trip distance and fare amount. And it's an interesting way of examining the data. And there are other plots available as well to us with respect to the filtered view of it. We can examine a scatter plot. And here's a scatter plot of the data. We can also look at the full filtered data set in the form of a box plot. And here's that plot for us. It's interactive for each variable concerned, each numerical variable. We can also plot the three variables in a three-dimensional perspective. Let's pick from the list of plots available to us a mesh three-dimensional view. And here's that view. Very interactive, easy to use, and we are able to examine the data in the 3 dimensions. So far, just to keep things in perspective, we were able to plot both the full view of the New York taxicab data file as well as its filtered view. And this completes our first scenario, whereby we initially started off with this large file. We were able to inspect it, we were able to clean it, we were able to come up with a filtered view of it, and then finally we were able to plot its data both from a full perspective and a filtered perspective based on the plots that we just examined. So this completes our first scenario. Now we can further on move to demonstrating the capabilities of this tool in terms of bringing up additional files to see what else we can do with it. Hello everyone. So previously we conducted a full pass-through of the data analytics and visualization tool utilizing one big file, and the file which we loaded up, it still is actually in the system right now, which is yellow taxicab data file. And as a result, we were able to filter it, clean it, and after coming through the inspection and cleaning stage, which is the first screen, and then we plotted this data. So now we also want to examine what additional capabilities this tool has that can be also useful to us. So we can demonstrate that by loading up another data file. So let's pick up from the list Dow Jones index file. So here's that file, and as part of inspection and cleaning, we previously demonstrated we could actually remove all of the missing value records. So we did that. And one additional thing that comes across as we analyze data files, because of the way the data is stored and classified in these files, you can see open, high, low, and close for stocks. It has actually the currency symbol in it as well. So let's examine as part of inspection how the data in these variables is classified. So let's look at the types report. You will see open, high, low, and close. The data is defined as a string. So having the data defined as a string would not be useful for us, especially in plotting, because it's not a numeric data definition. So this is another way where the tool enables us, for files such as these, we can actually clean up even prefix values for any given variable. So let's select, for example, as part of cleanup, the variable open, and we can remove the prefix. There you go. just point and click. We were able to now have open without any prefix, and if you run the actual report on types, open, you see it's now float. So it'll be very easy for us now to use this variable in plotting scenario. So this is another capability of the tool as part of the transformation features it offers us for cleaning up the data. And this is something that, as I had indicated previously, we run across quite often as far as being able to examine files where we are handicapped because the data itself has a classification which prevents us to actually leverage that data. So the tool allows you to do this as well. In addition to that, so far we opened up hierarchical data definition files, we opened up comma separated value CSV files, but just to give you an idea, we can also actually examine Excel files as well. So let's open up an Excel file, and here you have it. There's an Excel file. Again, as part of the cleanup, we can do things like remove all records with missing values for variables. We clean that up. We can also, for example, not only transform date from string classification to date and time, but in this case you can see only meaningful information for order date is the date itself. The time and hour, time, seconds, and nanosecond is of no value because it has all zeros. So we can even remove that as well as part of cleanup, and we can change the date to simply the date component. There you go. So we did another cleanup as part of our transformation capabilities of the tool. So this gives you a better understanding of the kinds of things we can do with this. We can actually perform in leveraging any data file to make it more useful to us. So this wraps up an overview in terms of what is possible as part of this data analytics and visualization tool to help us analyze, filter, and plot data. Hope this was useful to you. If you have any questions, any comments, feel free to get back to me as part of this demonstration and this video. You also have my email. Thank you.